welcome back to the Nexus Point. My name's Luke Cove and I'm here with Karl Jenson from currently working at iStore. How are you, Karl?
I'm good, thanks, Luke. Thanks for having me today. I like your new Powerball t-shirt. That's pretty cool.
Yeah, Tesla Powerball 3. Yeah, I wear the shirt a lot, actually. I got it for free. I pretty much only wear clothes that I get for free these days. I've reached that point in life. But yeah, look, Karl, thanks for coming in. Now, I wanted to get you in today to talk about predominantly the iStore heat pump and the other products that iStore has on the market. But before we jump into that, for people that don't know, do you just want to give me a quick rundown on what's your position in iStore and your experience in the industry?
Yeah, cool. Thanks, Luke. I've been in the industry for 15 years. I started out with one of the pioneers in renewables who were able to do remote site assessments. So that was a bit of a changing of the guard. So you could look at someone's house on the internet, get a satellite picture and quote their solar installation without going to site. I saw a great opportunity in the market for heat pump hot water, and that's a number of reasons. Australia's got nearly 12 million houses. We've got nearly 2 million solar systems that are renewable powered, being either rooftop solar thermal or heat pumps. And the other 10 million are split evenly, 50-50 gas and electric resistive elements. And those water heaters contribute to more than 20% of Australia's domestic emissions, which is a scary number, even in comparison with the amount of solar that we've got on the grid. So whilst we hit a new milestone last week, 4 million houses have got solar in Australia out of 12, so 30% of our homes have got solar systems on the roof. Every one of them's got a hot water service that is making more emissions than it should be.
Yeah, it's a really big industry. It's interesting that I remember you mainly from when we first met a couple of years ago, and then I think you swapped from a supplier to work at Tesla. Not at Tesla. You're working with Solar Juice, but you were supplying Tesla to me, and we did hundreds together, and it was great. And then one day you kind of said, "No, I'm done here. I'm moving over to hot water." And at that point in time, a few years ago, I was like, "What?" I didn't even have a clue. It seemed very out of character to go from solar and battery into hot water. But I remember you sat me down for lunch one day and you said, "No, there's an opportunity here. We've got to get on it. This is going to be huge." Was this as the early days of the Solar Vic rebate, or they just announced the $1,000 rebate? I think that was when you moved over to iStore.
The rebate had been around a while. It was just very difficult to get it. So when I introduced it to you, the process was 4-5 weeks to get an approval, and now you can get an approval almost overnight. Would I be right there?
Yeah.
Yeah. So you're a great early adopter, Luke. You came on new technologies. You jumped into electric cars. I said, "Hey, look, this electric car's fantastic." You went and drove one. I went, "Holy shit, got to get one of those."
Karl, you've got me into a lot of things over the years. You're taking credit for that. You just give me the heads up. I just follow you. I say, "What's happening next, Karl?" And then I'll jump on and then I'll try and make it mainstream.
Yeah, look, well, what is next? I think what is next actually is really, really important. I've found myself looking at so many different platforms for the different renewable technologies in my house that it's become difficult to manage. So I've got an app for my inverter. I've got an app for my EV charger. I've got another app for the other EV charger. I've got an app for my hot water service. I've got a different app for my battery. So now I'm looking at 5 different apps to try and manage my energy, which is really hard. And of course I say, "Hey Google, turn the lights on," and turn on the air conditioners and those sorts of things. So being able to integrate all of that stuff fairly easily, and when I say easily, it's got to be something that a solar installer can set up in a couple of hours. Otherwise, it turns into expensive, right? So that's what I think the next thing is going to be.
Home energy management is what you're getting at?
Or at least a platform that makes it easy to do most of it in one place, at least the major energy consumers.
Yeah, there's a lot of tech startups that are really kind of fighting for that space at the moment in the industry. I haven't seen anyone kind of come through. I mean, there's a few ecosystems that are quite good. If you go down the Tesla ecosystem, SolarEdge are getting there with their ecosystem if you go down that road. But yeah, we'll talk more about that later. What I wanted to talk about first was the iStore heat pump. Can you tell me about the history of the iStore heat pump, when it came to market, or how it was developed and how it's built over time, and how you're seeing whether there's been an uptick in the last few years? Is this what you're seeing?
Yeah, so that's a great question, Luke, and you don't know the answer, but it's really going to blow your mind. 10 years ago, I was still doing what I'm doing now, just under a different part of the business. And one of the business owners said to me, "What do you think of heat pumps?" And I said, "Absolutely, this is the way to go." Because you haven't got guys working on roofs with solar thermal hot water services. I was living in Perth at the time. Perth's a great climate for a rooftop solar thermal, except in summer where you've got 3 or 4 months where you just can't use enough hot water, and it results in boiling the water in the tank for hours and hours each day. So you've got boiling water running down your roof for months of the year, which is a terrible waste of water. And Perth is a climate that is, they don't have a lot of water. A lot of Perth's water is groundwater that's desalinated. They don't have a lot of water in dams. So it was quite wasteful. Anyway, I got a new house and boss put in a heat pump for me. We never saw the end of the hot water in Perth. It was fantastic for our family. It had run for a couple of hours. I thought it was magnificent. Anyway, one thing leads to another. That part of my life changed. I moved back to Melbourne. In the first 3 years of iStore, we sold around about 1,000 units, and these days we sell about 1,000 of them a month. So the growth over the last 10 years has been, that hockey stick curve that everybody says is incredible. But as it stands in the market in Australia right now, only 120,000 of the 800,000 hot water heaters that are installed in Australia each year are heat pumps. So that tells me that there's 680,000 fuck-ups. So those things we install will be creating emissions for at least 10 years. And of course, Saul Griffith's written a great book about it, 101 million machines to get rid of in Australia. Hot water services that are gas and electric fit into that category.
It's crazy when you talk about the difference between gas and electric, and one of the reasons why we think hot water is going to be a big industry over the next 10 years is as these old gas units die, or the storage units die, they need to be replaced. And I just think you'd be stupid to replace it with gas or electric resistance. It doesn't make any sense. So I can see every hot water unit in Australia needing to be replaced in the next 10 years, which means it's a huge job.
Yeah, so just Victoria alone, we've got 2 million gas hot water services out of the 5 million that are across Australia. So, 80% of Victoria's hot water is gas. And of course, gas has a great history in Australia. 55 years ago, they basically built the first gas wells out in Bass Strait. And they said this is a magnificent opportunity for Victorian industry because there's enough gas here to last for 50 years. That was 55 years ago. So we're well and truly on borrowed time now. And using gas to heat water is really dumb if we are still using it in industry, which we are, for process heat, where you need 800, 900,000 degrees. Gas is great for that, but for heating water, it's a waste.
It just seems like such a short-term solution. And I'm interested to see what happens in the future. I mean, you look at in America at the moment, we have old Drill Baby Drill, who wants to, you know who I'm talking about, wants to bring gas back, which I think even they know it's a short-term solution to maybe put them in a better financial situation, but I just can't see how it's going to be beneficial for them in any more scale than a couple of years. But yeah, look, it's interesting to see iStores really picking up, and when we jumped on a couple of years ago. So can you just give me a quick rundown now? In Victoria, we have the Solar Vic rebate, $1,000, and we have the STC rebate, and we have the VEU rebate, the VEECs. So that's about, $2,000 on an average?
Yeah, it's at least $2,000. A word of caution there for your listeners, Luke. This is the first year where we drop 4 STCs between this year and next year. So January the 1st, all heat pumps in the market will drop 4 STCs, whereas previous years it's only been 3. And that's because a heat pump typically saves 2.9 tonnes of emissions. Hence, if I add that up enough times, I need a 4 in there sometimes. So that rebate's going to decrease by $150 over Christmas.
Yeah, okay. What rebates are there around Australia for people listening outside of Victoria?
Yeah, good question. New South Wales has got a scheme that's very similar to VEEC's, which is a little bit less money. Queensland's got nothing. Northern Territory's got nothing. Western Australia's got nothing. And South Australia has got a scheme that's similar to Solar Victoria if you disconnect from the gas network. And that's paid for by responsible entities. They've got targets to meet. So if I had 20,000 certificates, I could trade until I hit my 20,000 certificates obligation, and then I'd just stop. So they're a little bit jumpy in South Australia with the rollout, as opposed to Victoria, where Lily's basically said, go for it. I'll provide as many rebates as you guys can use.
Yeah, that's good. It's good to see people getting behind the electrification. Some states taking a little bit longer than others, but yeah, I think Victoria is probably leading the charge. I hear New South Wales are really catching up with electrification. I think Queensland are maybe going to take a little bit longer with their electrification journey. They seem to be a little bit more on the other side of the fence currently, but they definitely have a big uptake with solar there, so I think they will come around. So I wanted to keep moving. I had a question about the iStore heat pump. Now, there's a lot of heat pumps on the market. There's some really, in my opinion, there's some really bad ones out there, and there's some good ones too. Where do you think iStore sits in the market?
I'm very, very lucky, Luke. Just like selling Tesla Powerwalls, they were the best in the battery space. iStore heat pump was the best in the heat pump space. Ultimately, there are some manufacturers out there in the market that overstate their performance. I'm always one to under-promise and over-deliver. And most heat pumps are good heat pumps. It's just they come in 3 different main sizes. One's only got 2 kilowatts of heating power, one's got 2.7, and one's got 4 kilowatts of heating power. The iStore fits into that high-powered category. That basically means that it heats the water faster, it recovers faster. So if I have a small heat pump and a large load, it needs to run a long time each day. So if they all run the same number of hours, the one that's got the most heating capacity, that takes the least amount of time to heat the water, is going to last the longest. And that's what we've found at iStore. We've been installing heat pumps now for 10 years, or selling heat pumps to the market for 10 years. And it pretty much works out that way. Obviously, people call us up and they say, I've got this heat pump and I haven't been very happy with it. And I say, is it just you and your husband? And she says, no, it's me and my husband and my 5 kids. And I'm like, there's nothing wrong with the heat pump, you just wore it out. So ultimately, that means that probably after this podcast, some manufacturers go away and scratch their head and come back and say, well, probably we need to build more powerful heat pumps, and that'd be good for the industry. But at the moment, I'm really lucky there's not a lot of competitors. Yeah,
you guys are definitely leading the charge with the all-in-one heat pumps. I did have a question around split tank heat pumps. Now, what do you think is the difference between an all-in-one and a split tank? And is that something iStore would consider, or are you comfortable with the all-in-one?
Yeah, look, at the end of the day, capacity is an interesting point of discussion. So we think if you need more than 270 litres of hot water with 4 kilowatts of heating power, that you should buy a second one, and that power to water ratio works really well. So I can heat a tank in 4 hours in winter. If I get a bigger tank, so a 400 litre tank, and the same amount of heating power, it takes 6 hours to heat it because the tank's 50% bigger. So split systems with different size tanks really make everything complicated in terms of getting product certified and carrying stock. So if you sold a 250 litre tank and you couldn't get one, you needed a 315 instead, or whatever, that complicates things for the market. whilst we haven't had our smaller capacity 180 litre heat pump now for about 6 months in Victoria because it has a less environmentally friendly refrigerant gas, it makes it really easy for me to only have to sell one product. So given the costs are greater, as soon as you put it in 2 boxes instead of one, you've got to build a steel chassis and an enclosure for it. It's significantly more expensive to build a split system type heat pump. And from a performance perspective, they both perform as well as each other, at least according to the VEU. They both save around 72 to 75% of the energy that an electric resistive hot water unit saves. And I'll add to that, most heat pumps in the market, that 70% number saving, and plus or minus a couple of percentage points, only equates to, say, 100 watt hours a day difference in consumption. So that's not a big deal. In terms of installation, it's harder work putting in a split system because there's more plumbing to do and it can take significantly longer. And that obviously adds to cost.
It does make it a little bit more difficult to install. You need a bit more space on the wall. So there can be more challenges around the split unit. That's interesting. It's good to hear your take on that. I wanted to talk to you about something. Now, when we were doing our showroom fit out, we had a box out the back.
We did.
We had a box out the back and you said, what's in there? And I said, I don't know, Karl. And you said, let's open it. Okay, cool. So we got the crowbar out. We opened the box and there was a unit that looked very similar to an iStore in there.
Yep.
It was black and it was labelled Reclaim.
Indeed.
What was that about? Are you comfortable to talk about this?
Look, at the end of the day, as an industry leader, our competitors are always trying to one-up us. And unfortunately, the Chinese didn't get the ethics classes that we did when I was working at Boeing. And the ethics class says if someone pays to develop a product, it's their product, it's not somebody else's. So it was a couple of phone calls and ultimately I believe that they're no longer offering the equivalent product to the iStore.
Yeah, it's wild. So basically there was a Reclaim. It appeared like Reclaim had gone to China and basically got the same unit and then made it black. Basically got an iStore, made it black and rebadged it Reclaim. Is that what happened?
Look, I don't know. Obviously, I don't communicate with our competitors. There is a couple of versions of the iStore in the market with other manufacturers. They're slightly different to ours, and at the end of the day, I think ours is the furthest down the road in terms of technology. Theirs aren't quite as good as the iStore. Ultimately, they're good units, and as I said, I think that all heat pumps are good heat pumps. We've got 10 million hot water services in Australia to change out, and currently there's a huge opportunity there for a lot more players in the market, and ultimately we hope that we can grow as fast as the market grows, but there'll always be opportunities for competitors, and obviously that drives the cost down for everybody in the market eventually.
Okay, so you think that you're an industry leader and people saw you guys were doing really well and then they basically just decided to mimic your product and come to market. But I believe they put a stop to that actually. So we got, essentially it's a prototype of a black unit that looks exactly the same as an iStore, but I'm told it's not coming to market. So maybe something happened there behind the scenes, maybe.
Let's say, hypothetically, if I go to a customer and knock on their front door and I say, hey, you can have a heat pump for free. Everyone says, yeah, let's go. That sounds fantastic. If it's $1,000, people say, how much money am I going to save? And if it's $2,000, you say, well, okay, that's a 3-year return on my money. I'm happy with that. When someone says to you, it's going to be $6,500, you go, wow, that's a lot of money, and gas costs 3 cents a megajoule. I don't think that that's in any way, shape or form realistic. So generally speaking, the players in the market that sell the most amount of product are the cheapest, and the players in the market that sell the most amount of the most expensive product sell the least. ultimately, iStore fits in the middle. We're not the biggest, we're not the smallest, and as I said, there's lots of opportunity there for others.
What do you think about, and I won't name any brands here, what do you think about the cheaper units are on the market? I know you can't get a unit for free anymore. Those days are done.
Those days are done.
But there's a lot of rebate chasers.
Yeah, back in the day,
vultures, whatever you want to call
a
them.
little bit of context around that. Back in the day, 5 years ago in Victoria, you could get about $6,000 worth of rebates to put in a heat pump, replacing an electric hot water service. So that's where the rebate chaser was born, because you could buy a heat pump for $1,000, pay a plumber $500 to install it, and collect $6,000 in rebates. So the free heat pump was never really free. The Victorian taxpayers paid for it in spades. Just run that. I went off on a tangent there. What was the question again?
I was just asking, what do you think about the people that are selling the cheap ones, the inferior units? Do you think this is a problem? Look, I guess I'm going to be more direct with my question. Do you think this is a problem for the taxpayer that's funding this whole operation for these hot water units that are unreliable and not what?
Okay, so I'll give it some context. You can only get Solar Victoria rebate once. You can only get the VEU rebate once. After that, you're on your own. So you can get the STCs again, which of course decrease each year. And next year, the STCs will only be worth about $650. But from an emissions perspective, it only takes a couple of months for a heat pump to pay back the emissions that it took to build it versus gas or electric. So if that heat pump lives for 6 months, it's saved emissions, it's employed some people, it's not the end of the world. My take on it is for people to do their research and look for units that have been around for a long time, that do have good service and support. And, we've definitely got those things in place. I love talking to iStore's refrigeration mechanic that does any complex repairs that we might need. He tells me that he's replaced compressors on 20-year-old Quantum heat pumps. Now, the iStore design and the Quantum design very similar, and ultimately I'm really happy to hear that tanks, vitreous enamel tanks, are still in service and serviceable 20 years down the line, and that it took 20 years for a heat pump that has the similar amount of power as an iStore before it died. That's great. We do hear the other end of the scale, which is my heat pump died in 4 years. I haven't had enough hot water, and so on and so forth. All of those heat pumps were low-powered heat pumps, and of course that means that they're bashing away all the time to put back that hot water.
So if someone bought a heat pump under, let's say, a government scheme, and that heat pump died in 3 years, 4 years, and that company was no longer around, or maybe it was warranted for 5 years, and then at 5.5 years it dies, then that homeowner's going to have to fork out for a whole new heat pump with no rebates after that, which is going to be significantly more expensive.
It will be in 5 years, yeah, because the rebate scheme, decreases by 4 this year, but 3 next year, and 3 the year after, and 3 the year after. So yeah, in 5 years they will be paying full price for it.
Well, they won't be able to get any rebate if you said they've already claimed it, right?
Yeah.
So they'll have to pay the full amount for the hot water system potentially in 5-6 years.
Even worse, like if they bought one that was the cheapest one that they could find, it will be the lowest powered heat pump that they can find because they're the cheapest. So something that's got 2 kilowatts of heating power. When they realise that that's not enough for their family, even though that's what it said on the box, they need to buy a second one. They need to buy the second one at full rate. And then they end up spending more money than had they bought one with twice the power in the first place.
One thing I've noticed about people in general, not everyone, but a lot of people, is they kind of think in time. They don't think through time in the sense of they don't think really too far into the future. They just think, I'm living here with my wife and 2 kids now and that's it. And all I need is this. I don't want anything bigger because that's all I need. And then all of a sudden they might have another kid rock up, or maybe a family member might get old and then they have to look after a family member, and their family size increases without them really predicting it a couple of years down the track. And then that hot water service that they've installed, for example, and there's many other appliances that this logic applies to, is no longer big enough and they have to upgrade. And it's an annoying thing to have to upgrade if you put in, hypothetically, a heat pump and then 2 years later your family size increases. Because I'm not argue, but I've spoken to a lot of customers that they're old retired. They go, I just need a 180. And we're like, at that point, it was like $100 more for a 270. Yeah. We're like, dude, just get the 270. Oh, I don't need it. I'm like, what have you got to lose?
Yeah, no one's ever complained about having too much hot water. No one's ever complained that their hot water recovers too fast. And unfortunately, we have to compete with continuous flow natural or fossil gas-fired hot water services. So obviously with one of those, you can get in the shower and have a shower forever because it's just raging away outside with this inferno to create the heat fast enough for you to use it in a shower. So those things recover at 500, 600 litres an hour, whereas a heat pump like an iStore is more like 90 and a low-powered heat pump's more like 45. So we've got to try and compete with a service that's been able to deliver a spectacular amount of hot water. But because that raging inferno is on the other side of your wall outside your house and you didn't hear it and you didn't see any of the emissions coming out of it, it was all fine.
So just to clarify for the people listening, an iStore 270 litre heat pump, how many people would you recommend in a household with a 270 litre?
Yeah. So on the timers for running it with your solar system during the day, it's good for 4 people in winter. If you take it off the timers, we do have customers in Victoria that have got 7 people in the house. At 7 people in the house, it's a struggle because obviously you've only got, well, not obviously, I'll tell you, you've got about 400 litres of deliverable hot water in winter. And that's because the cold water that we're mixing with the hot water in the tank is cold. In Victoria, it's down as low as 8 degrees. So summertime, I've got to heat water from 20 to 40 degrees for you to have a comfortable shower. Winter, I've got to heat it from 8 to 45. So I've got to put like 65, 70% more energy into the water in winter. And that's where your low-powered heat pumps come unstuck. So if I take the iStore off the timers, let it run day and night whenever it needs to, it can deal with a larger demand. But ultimately, if you want to put 7 people through the shower, one after the other, they're going to need to be pretty short showers.
Okay. If you run your heat pump 24 hours a day, more or less, then does that reduce the life of the heat pump?
Absolutely. Yep. I come from an aircraft maintenance background. That means that everything that I have, everything that I do, I see it has a life in terms of running hours. So aircraft are maintained 50 hourly oil changes, 100-hour service, 1,000-hour inspections, these sorts of things. Appliances, cars, all have similar, another term for it is mean time before failure. So I think that the mean time before failure for a heat pump should be consistent across all brands of heat pumps. I don't think anyone's using anything incredible. There's no breakthrough technology that anyone's using that's different to anybody else's. Therefore, if nothing else goes wrong, it runs for a fixed number of hours, give or take some tolerance before it's worn out. So if something does more work in the time that it runs, then it'll last longer.
Okay, so yeah, it's kind of like cycles in a battery. I know what you're saying. A lot of people think like that, particularly around electric cars now, how many cycles they can get from the battery. Another question that I get a lot though is people that live in the hills and areas that are particularly cold in the middle of winter. How does the heat pump handle those really low temperatures, or what's the minimal operating temperature that you can deal with?
Anyone would think we've talked about this before, 7 degrees is the magic number. So at 7 degrees, an iStore gets what's known as a coefficient of performance of 4. So for every 1 kilowatt hour of energy I throw at it, I get 4 kilowatt hours worth of heat into the tank. That's fantastic. I think that's awesome. In comparison with gas only gets 0.8, maybe 0.85 on a great day. So we're vastly more efficient than gas. But as that temperature drops, by the time we get down to 0 degrees, you're at around COP 2.2. So we've lost almost half of the performance. There's a number of reasons for that. The primary reason is as the temperature drops, the relative humidity, even though there's the same amount of water in the air, goes up. So I end up with, let's say, 20 degrees, I've got 50% relative humidity. If I cool that same air down to 0, it ends up at 95% relative humidity. So there's a lot of water in that air. And what happens is the evaporator needs to be below ambient temperature by about 10 degrees. So by the time I get down to 0 outside, the evaporator, which is harvesting the energy from the air, it's at -10. And any water in the air, doesn't matter what kind of refrigerant gas I've got, will freeze on those coils. And because it's freezing on those coils, eventually the airflow stops and I have to melt that water out of the evaporator again before it can restart and go again. And people notice this with their air conditioners. The handful of days in Melbourne where it's really cold morning, they say, oh, my air conditioner doesn't work. It's turned into a big block of ice outside. Answer for that is put on a jumper, wait a couple of hours, and then turn the heating on when it's a bit warmer outside. Heat pumps are great like that in that I don't have to run them at 0 degrees because they've got a large volume of stored water, so I can run them during the day when the temperatures are warmer than 7 degrees. And if I look at Victoria, the coldest place that we've got for the average daytime mean temperature is Mount Buller, and it's 4.9 degrees. 4.9 degrees, still getting COP 3.5, and that's in alpine country. So
the efficiency is down, but the unit will still work. It'll
still
be able to deliver hot water. And I think that's the thing is when temperatures are that extreme, you understand you are going to use more energy, particularly if what you're looking for is heat one way or another. So you are going to use more energy. But I think what people really want to know is on a freezing cold morning, are they going to have a hot shower?
Yeah, well, we've got 270 litres of stored water in that tank at 60 degrees. So let's say it heated up the night before, no one had a shower. In the morning, I've still got say 57 degrees hot water in the tank. I mix that with some cold water. I've got 400 litres of water that I can put through the shower. So if I had a 7.5 litre a minute shower head, which is a fairly standard water saving shower head these days, I've got about 55 minutes in the shower before the hot water runs out, even with it not running. So that's a pretty long shower. Unless I had 5 people in the house, then it's 10 minutes a pop. And of course, if one of them goes for a 20-minute shower, then, someone misses out.
Yeah. So iStore's been getting really popular in the last year or two. I'm noticing a lot of other companies offering it as well. How are you guys managing kind of quality control of all of the installers? Like, do you have an onboarding system with installers, or are people buying through wholesalers? Do you have any kind of quality assurance? Are you auditing any of these? What are you doing there to maintain quality as you increase the volume of installations? Yeah,
well, as you found out yourself, Luke, not all plumbers are created equal, and not all customers are equal either. So usually the problems that we experience are with the customer's plumbing, not necessarily with the iStore. And fortunately, our tech support team at iStore is made up of half a dozen plumbers. So they take it in a rotation on the phone support line for us. And anytime a customer's got a problem, they can call us up and we can help them get through the problem. It's normally not a problem with the iStore, it's some other plumbing problem within their house. But the fact that we've got that expertise there makes it really easy for the end users to get a solution.
Yeah, a common complaint that we get from some people is with moisture coming out of the PTR valve. Yep. Is that a normal thing?
Yep, normal for all heat pumps, all hot water services actually. Okay. What happens in a gas, let's say I had a gas storage system, it would recover at close to 200 litres an hour. So as I'm in the shower, it's able to almost keep up. So the pressure that's building up in the tank from the fact that I've got a raging inferno underneath the tank is actually being dissipated by the fact that the water's coming out of the tank. But when I slow it down and I need to reheat the water over, say, a 3 or 4 hour period and no one's turned the tap on, little bubbles form on the inside of the tank, just the same as when you turn the kettle on and look at the element, there's little bubbles forming on the element. Same thing happens inside your water heater, and those little bubbles take up space, more space than the water, and so the pressure inside the tank goes up, and that's what the PTR is for. So it will generally drip after about an hour of running, and then once the unit's stopped heating, then it might run for another 10 minutes or so, and then it should stop. But PTR valves, nightmare for all heat pump manufacturers, all hot water system manufacturers. Obviously, we don't make it ourselves, and it's probably our number one point of failure within that 5-year period. So the valve's only warranted for a year. Unfortunately, it is a consumable part. And whilst I don't encourage people to go to Bunnings and buy one and install it to themselves, if you could use a spanner, you could probably do that.
Yeah, okay. I wanted to talk about refrigerant as well. So you guys previously had the R134A refrigerant, and now you've moved over to the R290. Now, that was a regulation change, correct?
Yeah.
So tell me about that. How was the process transitioning? Was that hard to change to a new refrigerant, get reapproved and everything?
It was really hard. So we anticipated that process would take about 6 months. It ended up taking more like 18 months, so that we were actually late to bring our product to market. We thought, we had a budget for that change, and we didn't think that it would be a significant amount of money, and it turned into a spectacular amount of money. By the time we incorporated a number of other changes and improvements to the iStore. So with 10 years of experience, we know what our customers want. We know the things that have caused us pain and suffering and failures and so on over the journey. And that experience enabled us to improve on all of those parts. So there were more than 70 changes to the iStore from the old model to the new model. A byproduct, it got bigger. So the heat exchanger that harvests the energy from the air with propane needs to be much bigger. And that's one of the reasons why a lot of our competitors have got units that are lower powered than the iStore, because the physical space that it takes to put an evaporator in there that can harvest 4 kilowatts of energy from the air is quite big. So unit got taller, evaporator got bigger, the compressor size stayed roughly the same, but because of the change in refrigerant gas, the nominal power input that it needs to run actually decreased. So we went from a heat pump that had 940 watts of input power to one that now has 850. So we've dropped by about 90 watts. That's a good thing, because our heating output power climbed from 3.6 kilowatts to 4. So in doing that, we gained a couple of certificates, STCs, a little bit more rebate. That's because it saves a little bit more energy over the next 6 years. And ultimately, if you boil it right down, we gain 2% better performance. So it's not huge, but every little bit counts. We're happy with that.
Yeah, no, it's good to see you guys moving over to stay with the times. I mean, you're kind of forced to by the regulations, but that's good. One thing we get on Facebook, there's been a few arguments between some people in the comments on Facebook about the claim that and all hot water's heat pumps kind of do it. The claim that the iStore is 400% efficient. And now someone goes, well, you can't be more than 100% efficient. And I think you actually touched on it before, and I wanted to pull you up on it. But do you just want to quickly explain how the iStore is actually 400% efficient, the logic there? 400%
at 7 degrees. So heat pump manufacturers rate their heat pumps typically at 19 degrees. And at 19 degrees, an iStore gets COP 4.85. That means that it's 485% efficient. If I pick a hot day, so last week we had the first 30 degree day in Melbourne, I have mine set on a timer to run from midday. At midday it was already 30 degrees, and I looked at my energy usage data and it had finished in an hour and a half, and I thought, wow, that's incredible. So I ran the numbers. At 30 degrees, I'm getting almost COP 6, so I'm getting 600% efficiency, which is just incredible. That's not a good measure of performance though, because it's not 30 degrees in Victoria very often at all. And if I was to tell you that it got COP6 in winter, you go, well, this isn't happening. So seasonal COP is another term that's used in the industry. And the other thing is that coefficient of performance varies a lot with the temperature of the water, as well as the temperature outside, as well as the relative humidity. So better way of modelling a heat pump is with what they call a Trinsis test. And it's put in a laboratory. Our heat pumps are tested in Australia. We want to know that you're getting a high performance heat pump as well. And it's not that we don't trust overseas labs to test our products, but they get tested here in Australia by Vipac, and Vipac tests a number of brands here, and hence we think that that's a reasonable place to get it done. It's a NATA certified lab. That gives us a number that we put to the Office of Renewable Energy Regulator, and they give us rebates based on those results. So that's the fairest way to test a heat pump, and it tests the heat pump over a wide variety of Australian conditions, and that's why we have different zones in Australia as well. So zone 1 to 5. Zone 1 is Northern Territory, North Queensland. Zone 3 is New South Wales and South Australia and Western Australia. Zone 4 is most of Victoria. Zone 5 is Tasmania and some high country in Victoria. So funnily enough, the colder the zone is, the more energy a heat pump saves. So we get more rebates in Zone 4 and 5 than you do in Zone 1. And that's because in Zone 1 in the Northern Territory, it's 33 degrees all year round. Their cold water comes out of the tap at 25 degrees. So they need less energy to heat their water than what we do down here in Victoria.
That's interesting. So yeah, the heat pump's going to need less energy in summer. That's good to know, which is interesting because that's when a lot of our solar owners have such a lot of energy that they're looking for somewhere to put it. So yeah, maybe you need a battery. But yeah, no, that's interesting to balance out. I wanted to talk to you about the inverters and batteries that iStore have brought to the market. Now, I think you've been on the market for about 12 months now.
Yeah.
Now, what makes the iStore inverters and batteries stand out? What do you think is a reason that a homeowner might consider that opposed to something that's already on the market?
Yeah, okay. iStore inverters aren't new. So they were sold in the market via their original manufacturer in the 5 years prior to becoming iStore. So there's more than 30,000 of them out there in the field, and they've been the most reliable product that the most reliable inverter, I should say, that we've ever sold. Ultimately, they gave us a lot of confidence in the product when it was offered to us to be what they call an ODM partner. There's a large investment from iStore in terms of needing to commit to stock volumes and get all the products certified in Australia under our own brand. So that means submitting all of those products to the Clean Energy Council for the process of getting them approved under the different schemes and all the different networks across Australia. The last 12 months, the range has been quite narrow. We had 5 and 6 kilowatt single and 3-phase inverters, which suited a small portion of the market. At All Energy, we launched our 10 kilowatt 3-phase, 15 kilowatt 3-phase, 25 kilowatt 3-phase, and our 10 kilowatt single-phase inverters. And we've seen an absolute explosion in demand on the East Coast, particularly because a 5 kilowatt system is just not big enough anymore. By the time we've electrified our house, we've started out with 16 kilowatt hours a day of demand for the average Victorian household. We've added another 16 kilowatt hours of demand if we've taken away their gas heating and their gas hot water. And then we've probably added another 16 kilowatts of demand for their electric car. So we've tripled their energy consumption. They need a solar system that's triple the size. So to have a 15 kilowatt 3-phase hybrid, 25 kilowatt 3-phase hybrid, we've literally had to air freight them because the demand's been so strong. And when I touched on before, having multiple apps for running all my different things, the iStore has its own EV charger. So the EV charger will ramp up and down with the output power of the inverter. And it also grid limits. So it has smart, so that in winter when your solar system isn't generating much power and you're heating your house flat out, you're trying to charge your car, it's really easy to run out of network connection on single phase. So it manages that connection as well. So we're doing that under the one app. The heat pump gets added to that app in January. So customers will be able to go to their Universe app and change the times when their hot water service runs, so they can match that with their solar as well. And on top of that, we're compatible with Catch Power and Village. Village is a great bit of kit. It enables people to integrate with services like Amber and participate in the wholesale energy market. And it also has air conditioning controllers. So just the same as Sensibo, the air conditioning controllers are like an IR blaster that talks to the remote control or talks to your split system aircon. So I can set parameters in that software to say, when I'm producing 3 kilowatts of power, turn on this air conditioner, turn on that air conditioner.
How does it communicate with the air conditioners?
Yeah, so it's using, it's called an IR blaster. So I'm doing it home with a thing called Broadlink. They're about $30 each. Sensibo's about $100, and you can basically automate your house from your phone with third-party devices. So by using Village, the Village is talking to the inverter network. It's seeing how much surplus I've got because I've got a smart meter in the board. It's able to link all of those products together and simplify what I have to do. So ultimately, I don't want to be a slave to my house. I don't want to be a slave to my electric car. I don't want to have to manage the state of charge of my battery. I want it to do all of those things all on its own. So the buzzword's going to be AI. So AI is going to do it. So the question is, how much AI do I need to manage my home things? And the answer is actually not a lot. You really just want to run your hot water when your solar system's generating power. That's always going to be 10 till 2. That's the middle of the day. That's when you want to charge your battery if you've got an export limit, so that you don't go over your export limit. So I want to delay charging my battery. I don't want to start charging at 6 o'clock in the morning when the sun comes up. I want to wait until I'm otherwise throwing energy away. And all of those sorts of things are going to be more mainstream going forward.
Yeah, it's interesting. There was an article in the ABC last week. Someone was having a bit of a Yeah, I know. I had a few words to people at Tesla that were pretty high up, and then I started a fight with a guy on LinkedIn. It was hilarious. I think they were like sending screenshots right up the top at Tesla. But the guy, he was from a company that does, it seems like home energy management, and he was looking for interoperability of this Tesla Powerwall systems, which essentially I think means open up the API so other apps can control it, or customers can control the battery themselves. Because like for Tesla, for example, they can sign up to a VPP, but they can't necessarily tell it like with a button charge or discharge. I'm not sure if they can with Amber. But is that something that you guys are looking at to giving, I know you said AI doing it, but what, a lot of customers are actually want that control themselves, whether they're going to use it or not, but they want to be able to do it. Is that something that you're going to give customers the power to say, dump the battery to the grid, or is that something you're going to retain that power?
It's funny. That's why I have an iStore on my house, because I can do those things. I just don't know that I want to do those things going forward. Like at the end of the day, I want to make sure that I'm a big believer in not guinea pigging the customers. So that means that everything that we supply to the market is mature, and it's not a surprise for an installer. It's something that they can put on the wall, turn it on, and it'll work. It'll do what it needs to do. So right at the moment, iStore isn't compatible with any VPP, but that will come Q1. The reason why that one hasn't been urgent for us to get done is currently the VPP plans don't pay enough money to justify discharging your battery. So if your battery costs you 50 cents a kilowatt hour to put a kilowatt hour through, and someone says, I'll give you 25 cents, you might as well not do it. You might as well just sit on your hands. There's lots of different opinions out there. It might make sense to discharge it at 25 cents a kilowatt hour if someone paid you 15 cents a kilowatt hour to charge it. And that does happen on Amber from time to time. I looked at it at All Energy. to show a customer what you could see in the dashboard, and you could see that the network or the wholesale rate for electricity was negative 45 cents. And you're like, wow, if only I had my car plugged in, I could dump some power into the car and get paid.
Yeah, it's interesting. A lot of customers, they want that. And actually, I won't even say a lot of people. I'd almost say there's a vocal minority of people that want that control, but they don't realize that there's actually very few instances where that's going to benefit them, or where anything other than automating it would actually be to an advantage to them. And the other thing that I think about is people that want control of the API to let any random app out there. It's like when you get a Tesla car and you're limited to the apps you can put on that car, because they don't want you to just crash the whole OS while you're driving. So they don't want like I saw one happen last week. They don't want anyone to add any app to that car that can then control the car and could basically ruin the customer's experience.
Well, as you know, Luke, I've got a really old Tesla. It's 8 years old.
Was that you that crashed last week?
No, I haven't crashed it. But it was the same type of car as what I've got that crashed last week. Yep. But it doesn't have any autopilot features. And if you leave it alone in the garage for 4 or 5 days and don't drive it, it goes into a deeper sleep than it would normally, and it shuts down all the computers. So when you get in the car, it's dead. And of course, because you're driving the car every day, normally you get in, everything comes to life immediately. When you get in and nothing happens, and you're pressing buttons and nothing happens, very, very scary. Because if anything goes wrong, your average mechanic can't fix it. You can't drive it anywhere. You can't start the engine. There's no button to push. So it's a heart-stopping moment as to whether it comes alive. So I see absolutely why Tesla is reluctant to hand out that API to anybody. And at the end of the day, the bit that guy missed is that Tesla is being very careful with their customers' personal security and their data. And I think that that's important too. So it's one of the things that we did with iStore. We managed the data and the monitoring ourselves. So that's not managed by the factory at all. It's handled by us, and all the servers for that are in Singapore. So we maintain that data integrity for our customers as if it was our own. And I think that the fact that Tesla's doing that is actually protecting their customers, and some people do need protection from themselves.
Yeah, I'd agree. Some people do need protection from themselves. One thing I will ask you, just because I know there's probably a lot of people listening that really want to know, because I get asked this every single time I talk to someone, they ask about vehicle to grid. And now I know, yeah, every time we do a workshop, every time we do a podcast, we'll ask them about vehicle to grid. So that does iStore, we'll put you on we'll make this the last question. Yeah. We'll wrap up on this one. Yeah. But does iStore have plans on doing any vehicle to grid in the future? Or vehicle to home?
Of course, everybody's going to have that vision, and ultimately the technology already exists in the inverter to do it, in that it runs the battery voltage for its single-phase inverters at around 400 to 500 volts. That's what an EV car battery is. And in the three-phase, it runs the battery around 750 to 800 volts, but it can run the battery at lower voltages. So that means that the inverter hardware is capable of dealing with 400 volt up to 900 volt EV architecture. All I'd need is a plug to connect it to the battery ports of the inverter, and I'm away with vehicle to grid. So from a technology perspective, it's not that difficult. I think from an early adopter position, I'm an early adopter. I've got an EV, I've got a home battery, I've got a solar system. For me to make the leap to vehicle to grid right now, it's very expensive, and it doesn't actually offer any benefits to anything other than what I've already got. If I was to delay buying my electric car to wait for vehicle to grid, I think realistically you'd be delaying by 5 years, and that means that you're missing out on 5 years of fantastic motoring in magnificent cars that are all electric that we've got right now. So I look forward to that part of the future where that technology just happens. But I don't think people are going to go out of their way right now to spend $10,000 on a hope and a prayer that it might work. Or it might save them any money. At the end of the day, if I told you you could save $5,000 a year, you'd say, show me the maths and I'll put the money up. But as it stands, network rates on the grid just aren't good enough to show any financial return, so they won't do it.
I'm thinking that to really profit out of it, have a big system on your roof, like a 20 kilowatt system, and then during the day charge it into your car and then discharge it back to your house. As opposed to, I think some people have some idea that they're going to go charge somewhere else for free and then bring it home. I don't know, maybe all the free charges are going to be taken. They're all going to be shut down. All of the free destination charges will be shut down once vehicle to grid comes out, because too many people are going to be taking advantage of it. Which is funny, actually. We had a free charger out the front of our warehouse at Lightning Energy at Clayton. And we had one guy who would just park there all day and sit in his car and start working from a laptop in his car. And we eventually had to shut the charger down because he was people were taking advantage, which, I mean, I don't know, maybe that's my fault, but anyway. But yeah, it's good to know that you got vehicle to grid coming. Yeah, look, I think that's all we really wanted to know, unless there's anything you want to touch on while you're here.
Yeah, one last thing, Luke. You know, the rego of my two cars, one's flat bat and the other one's charge me.
You want to sell them?
No. Between the two cars, my biggest challenge has always been charging them at the lowest possible cost. So if I charge it from the lowest possible cost, it probably comes from the sun, right? Yeah. So if I then discharge my car in the evening to the grid to help the grid out, I've still got to put that power back in at some point. So I need to buy a car that potentially got a bigger battery. Anyway, at 9,000 kilowatt hours a year that I put in the two cars, vehicle to grid and me using those batteries for purposes more than just driving them, actually run out of time in the day to be able to do it.
Yeah, it's a lot of transferring power around in circles, kind of a bit of a washing machine of power.
Greenwash.
But it's greenwash. Yeah, it's greenwashing. Nah, it's interesting though, because I mean, previously I've always wanted to like charge the car off solar, and then we got on an like OVO EV charging plan, which I mean, not to shill anyone here, but we were on OVO, and I think AGL and a bunch of people do it, and I kind of realized, I'm like, wait, I can charge my EV overnight for 6 cents, and they said we could feed our solar back to the grid for 10 cents during the day. I'm like, wow, I actually don't want to charge my car off solar anymore. It doesn't make sense. It's so counterintuitive. I had to fully change my mindset around it.
Yeah, absolutely. I did the same thing last year. I used lots of grid power and exported my power to the grid. Obviously, that's changed now. A feed-in tariff's only 3.3 cents and the EV tariff's 8, so I don't want to charge it at night. I want to charge it during the day. But if we just take one step back from vehicle to grid, those energy retailers like Origin and AGL already have software systems in place that can reach in and see your car, see that it's plugged in, and see how much energy it's used, and they can turn that demand on and off on the network. There's an enormous amount of power that we can have there, and obviously there's stuff in the news about surplus energy in the grid. What are we going to do? How are we going to ramp it down? I think the best thing that Australians can do right now is go out and buy an electric car.
That kind of fixes a lot of problems, I think, if there's too much energy in the middle of the day. Just charge up the cars.
Yep, we've got a lot of cars.
Well, we're getting there. Yeah, we're definitely getting there. I've got a few, as you know. My team, my sales team are the luckiest people in the world. They get to drive around in brand new Teslas.
Yeah, look, at the end of the day, Australia typically sells 1 million new cars a year. And if we're lucky to sell 100,000 electric cars, if that was 1 million EVs, we've still got 20 million cars on the road. It'd still take another 20 years if we were selling 100% EVs to get rid of all the petrol cars that we've got. So let's get cracking, mate. That's a job to do.
Yeah, it's going to put a lot of pressure on the grid, which is going to create a lot of work for electricians, which I'm excited about. Personally, from a business perspective, that, yeah, let's crank up the demand on the grid. So we've got to do a lot of upgrades, although mains upgrades are really painful. I don't like them at all.
Straightforward enough, right? So people used to go to the petrol station on a Wednesday or Thursday because that was the cheap day of the week. When they go out and buy an electric car, they say, hey, you know what? I should put a petrol station on my roof.
Yeah, well, I always say if you could put an oil rig in your backyard, would you do it?
Absolutely. Let's go.
Yeah, why not? If you could, you would. Well, you can put solar panels on the roof. That's the next best thing. Well, it's actually better. It's more efficient. It's cleaner. It's cheaper. Why wouldn't you do it?
So funnily enough, a great thing just happens to be a pure coincidence, but the amount of energy that a heat pump saves versus a resistive electric hot water service will drive a Tesla 17,000 Ks a year. So all you need is a heat pump.
That's all you need. We're going to electrify everything. No, it's good. Well, thanks for coming in, Karl. That was a great chat. And,
always great. Always a pleasure, Lee.
We'll have you back again next year.
Awesome. Looking forward to it.
All right. Thanks, Karl.
Ciao.
All right. See ya.